Notes 3B, rate of change. Objective, I could calculate the rate of change in algebraic and real-world contexts. Essential question, how do I determine the rate of change given a word problem? While you're taking these notes, make sure to join the Pear Deck and contribute to the slides, watch this video, fill out your foldable, and ask questions as needed. On your Pear Deck slide, drag the icon over your favorite season. Is it spring, summer, autumn, or winter? Here's your vocabulary. Become familiar with this. Rate of change, slope, the change of 1 unit per divided by another unit. Rate of change from a table review. So we'll find the change of x and the change of y. We also did this in 3a. -1 to 0, we add 1. 0 to 1, add 1. 1 to 2, add 1. 2 to 3, add 1. So your change of y over change of x is 1 over 1. That's just 1. Your b is going to be 2. So your equation is y equals 1x plus 2. Now let's just say there's an instance where they didn't give you x equals 0. When that's the case, you would just solve for it. You would solve for the b here. You get b equals y1 minus mx1, where x and y are some other numbers in the table, and m is the slope that you found. Rate of change from a graph review. So this is increasing, it's a positive slope. We have 2 lattice points here, rise over run. Let's assume that the increments is 1 since it doesn't give us any numbers. So our rise is 1, our run is 2. We have 1 over 2. It's positive because increasing. B is the y-intercept. It looks like it's about -1.5. So y would equal 1/2 x minus 1.5. A way to check to make sure that that is the correct b is to plug it into the point slope equation, the point slope equation. So y minus y1, we could just say this is x1, y1. So it's -1, -2. So y minus -2, which is just 2, equals a slope 1/2 x minus x1, which is plus 1. Okay, y plus 2 equals 1/2 x plus 1/2. Subtract 2. And then you get y equals 1/2 x minus -2 plus 1/2 is -1.5. So in this case, B was correctly identified. It might not be always that easy to identify B though. So you can always plug it into the point slope equation. Story and equation. So we're going to a carnival. The entrance fee is $3. It's $2 per ticket for each ride. You can only purchase for 1 to 5 tickets. So to model this, we can have y equals 2x plus 3, where 2 is how much money it is per ticket, and 3 is the entrance fee. You only have to pay the entrance fee once, but you might ride more than one ride, and so that's why 2 is the one that's with the variable. So they plugged it in where there's 1 ticket, 2 tickets, 3 tickets, 4 tickets, and 5 tickets. Now let's just say they didn't want to ride 8 rides. It would still cost $3 for the entrance fee. Here it is as a table. Here it is as a graph. Notice it is discrete. And we have the slope, we have the y-intercept. The constant is just that $3 entrance fee, and the $2 is for the slope. Okay, on the next slide, you go ahead and do this one. Choose an option. A library has 8,000 books and is adding 500 more books each year. What is the rate of change, M? Is it 8,000 books, 16 books per more books, 500 books per year, 4 billion books squared, or none of these? Rate of change for a word problem. At the start of a carnival, you have 50 ride tickets. Each time you ride the roller coaster, you have to pay 6 tickets. So your slope would be -6 because you're decreasing the amount of tickets you have. And your original amount of tickets you had was 50. So your equation would be y equals -6x plus 50. Rate of change for a word problem. Here's another example. A hiker is on a hike. After 2 hours, he is at an altitude of 400 feet. After 6 hours, he is at an altitude of 700 feet. What is the rate of change? Write an equation in slope-intercept form to model this. Oh, and the initial altitude is 250 feet, so we'll put that right here. So, this would be x1, this is y1, x2, y2. So let's plug that into the formula. Write out your formula, even if you have it right next to you. Let's plug those in. So I have 700 minus 400 all over 6 minus 2. That's 300 over 4. If we divide those, we get 75. So your slope is 75. Now let's see how we got that 250. Let's plug it into y equals mx plus b. So let's just say we have y1, x1. So then we have 400 equals 75 times 2 plus something. Okay, 75 times 2 is 150. Subtract 150 from each side. So we have 10 minus, we have 0 right here. 10 minus 5 is 5. And then this 3. 3 minus 1 is 2. 250 is B. A lot of times they will not give you the initial value for B, and you'll have to find it. You could use this formula, or you could use the point slope formula. So our equation is y equals 75x plus 250. So how do you feel about today's topic? Drag the icon over which one you feel for this topic. Are you not sure how to do it yet? Is it familiar? You know how to do it? Or can you explain it to others? Which level do you think you are with this topic right now? On the next slide, go ahead and fill out your daily reflection. 1. Define the rate of change, and 2. Provide a real life example. Type your responses.